Good evening, friend. Hello. Shall we start?
Yes, madam, we can start.
Actually, good evening to all. Today we are going to talk about broadband and FTTH overview. Myself, Nandini, working as a junior telecom officer in RGMTTC BSNL. Actually, we are going to see about today the broadband overview and FTTH overview. Actually, this is the broadband overall architecture. In this overall architecture, we are having some. Actually, this is the overall architecture block diagram of a broadband. In this, actually, these are some of the endpoint devices we are having that we are connected to the broadband network. That is, sometimes some of us may use IPv4 or some may use IPv6 devices for their devices or for their uses. Actually, these are connected to a access node, IPv access node. From access node, it is connected to a BRAS. BRAS is nothing but a broadband remote access server. That is sometimes BRAS is also called as broadband network gateway. Actually, the BRAS, the function of from access node to BRAS, actually, excuse me. Actually, the broadband remote access server is also sometimes called as a broadband network gateway. The main function of broadband remote access server is actually it provides the connectivity between the end user and the provider edge router. PE is nothing but a provider edge router. BRAS sometimes called as broadband network gateway. Actually, this is the main function of it provides layer 2 connectivity and layer 3 connectivity. Sometimes layer 2 connectivity means it acts as a transparent bridging between the access node and the provider edge router. Sometimes if it acts as a layer 3 connectivity means it what it does it means that broadband remote access server the IP traffic regulates the IP traffic through ISP network to the internet. That is internet service provider network to the internet. That is this provider edge router is maintained by the ISP network providers, that is internet service provider. That sometimes the access, actually this broadband network provides the IP traffic through ISP network, that is backbone network to the internet. And apart from that, BRAS access node, and we are having one more terminal called GGSN. Actually, GGSN is nothing but actually it provides the connectivity between the wireless network to the provider edge router. Actually this GGSN is used in terms of wireless connectivity, that is mostly in the in mobile communications. That are if you are accessing the data connections through mobile, mostly it is wireless, and it access the wireless data. That GGSN is converts these connectivity and it connects the connected to the provider edge router, GGSN. Actually, after that, we are having some NAT is nothing but a network address translator. Different users may use different protocols. That is, some might be use IPv4 or IPv6. The main function of network address NAT is to convert the private IP into a public IP. Or while they are using or accessing the internet in a public pool, actually individual users have their own private IP. While the private IP cannot be addressed in a overall internet network, since it should have a public IP. The main purpose of NAT is it is converts the network, converts the private IP into a public IP. Apart from that, in the control panel, we are having some separate servers, that is DNS, AAA, HSS, DRA, DEA, PCRF, and OCS. Actually, the DNS is a domain name server. Actually, the main function of the DNS is actually it provides assigns IP address. Actually, it converts or that what we are the names to a particular IP address. It maps the or translates the domain names to the IP address. Whatever we are typing in the Google search or whatever it is, it converts the domain names to the IP address. The conversion of domain name to IP address is the main function of this DNS servers. Next is AAA or AAA and HSS server. AAA is authentication, authorization, and accounting. AAA is meant for authentication, authorization, and accounting. Before a user is making a call, if he or she is accessing the data, first the main purpose is to authenticate the user, whether the user is exact, the current the particular exact person is using or not. Next, second function is to grant access to the network. That is if it is verified that the exact user, that the particular user is authenticated. Next, the second function is to authorization. We have to provide or grant access to the network for the usage of the user. Next one is accounting. Accounting performs the function of information, that is necessary information is collected for billing purposes. At which time, for example, if they start a call in particular time, and they may end a call in some particular time, or they use the data in access the data in some time, and they may end the data in some other. The necessary information is collected by this accounting server. Actually, the AAA server is authentication, authorization, and accounting. These three functions, actually these functions are performed by the AAA server. After that, we are having some HSS server. HSS is nothing but home subscriber server. Actually, this home subscriber server has the subscriber database used within the IP multimedia system. That is, the details of some of the subscribers are stored in this database of this HSS. Actually, HSS has the database of the subscriber, which provides the subscribers to other entities within the network, whether the subscriber is having which plan or belongs to which plan. For everything, the database of the server is, of the subscriber is stored in this HSS server. Apart from that, PCRF. PCRF is nothing but a policy and charging rules function. Actually, this PCRF server determine the policy rules in the network. That is, it provides some resources for IP multimedia system. That is, for a particular plan, it should have this much of data, or for a local call, it should through only until this and for entire that policy and charging rules will be performed by this PCRF function. Then we are having some OCS server. That is, OCS is nothing but an online charging system. This online charging system allows a communication service provider to charge the customers in real time on based on service usage. This actually, as per the usage of the server, this charging system will calculate the charge of the customers while they are using in the real time based. Are you able to understand?
Yes, ma'am.
Okay. Actually, these are some of the endpoint devices. We are connecting the endpoint devices through some access node to BRAS or BNG, that is broadband remote access server. Actually, this is a GGSN for some wireless communication. Entire whatever it is, GGSN or BRAS is connected to a provider edge router. This provider edge router is maintained by the ISP, that is Internet Service Provider. And NAT is the function. NAT is also a protocol that translates the private IP into a public IP. These are in control panel. We are having different type of servers, that is domain name server, authentication, authorization, and accounting. home subscriber server, then DRA, DEA, PCRF and OCS. Actually, this is the OSI model of the OSI model. We are having, actually, everybody knows that we are having 7 layers in the OSI model structure. The first layer is the physical layer. Second one is the data link layer. Third is the network layer. Fourth one is transport layer, session layer, presentation layer, and application layer. These are some of the functions and protocols used in the particular layer. In physical layer, actually, we are having some hardware means of sending and receiving bit streams on the carrier. Whatever hardware or equipments or systems, it will come under the physical layer. For example, USB, Bluetooth, these are some of the devices or whatever we are using in the physical layer. In data link layer, the main function of the data link layer is for error detection and flow control. And the protocols we are using in data link layer is ATM, slip, frame relay, and some P2P. ATM is nothing but a asynchronous transfer mode, and a frame relay PPP is a point-to-point communication. We used to say it as a point-to-point communication, and a slip, actually we used to say that a serial line internet protocol. Actually, for a serial line communication, they used to have this slip protocols. In network layer, actually the main function of the network layer is to address and routing. The function of the network layer is for addressing and routing the data packets or data frames. The protocols used for network layer is IPv6, IPv5, sorry, IPv4, IPv6, IP security, sorry, IPsec, we used to say this IPsec as Internet Protocol Security. Actually, the main function of the IPsec is to secure data when it travels over the internet. It provides some security, that is, it provides the function of, it provides some transport mode or tunnel mode, that virtual private network in the IPsec, and it transmits the data. Next, it is go for ICMP. ICMP is an Internet Control Message Protocol. Actually, this ICMP protocol is mostly used for reporting errors and performing some network diagnostics. If there is some problem in the network, it is used for reporting. Actually, it has some codes and protocols. It will display as the error according it has in the network. IGP and EGP is nothing but an interior gateway protocol and exterior gateway protocol. Actually, interior gateway protocol is nothing but a protocol we are using within an autonomous system. Actually, autonomous system is nothing but actually we are managed and controlled by a single entity, or actually a network that is managed and controlled by a single entity or a single organization. We used to say it as an autonomous system. If you are using a protocol within an autonomous system, we used to say it as a IGP, Interior Gateway Protocol. If you are using a protocol within different autonomous system, we used to say it as EGP, Exterior Gateway Protocol. Next, the transport layer. And the main function of the transport layer is to segmentation, acknowledgement, sequencing, duplicate detection. The protocols we are using in layer 4 transport layer is TCP UDP. TCP is a transmission control connection. It is a connection oriented protocol which helps in exchanges of messages between different devices. Actually, we are using TCP IP. It is a part of transport layer protocol. Then UDP is a user datagram protocol. For example, if you are downloading a game or playing video, that will come under our UDP, user datagram protocol. Next one, the session layer. The establishing and maintaining and termination of session is maintained by this session layers. Actually, if you are making a call or if you are accessing a data, first the session should be initiated, whether at which time the call can be started. Everything it is depends upon this SIP, that is session initiation according to this protocols. The protocols we are using in a session layers are PPTP, SIP, SAP, and NetBIOS protocols. PPTP is a protocol that is a point-to-point tunneling protocol. Actually, for tunneling means if you are transferring a data in a public network, it provides a secure transfer of data from a client to the public internet. While providing that, while in terms of secure, it provides it creates a virtual private network for that particular data. That is, we used to say it as a tunneling. It follows the tunneling procedure. That is a point-to-point tunneling protocol. Next one is SAP. Actually, SAP is nothing but service access point. The service access point identifies the label for a network endpoints used in OSI layer. For different networks, we used to have some different labels. These labels are identified by this SAP SAP protocol. Next protocol we are using is NetBIOS protocol. NetBIOS is nothing but Network Basic Input Output System. This Network Basic Input Output System enables application on different computer to communicate with each other. Actually, what are all the input output system that are using in application of different computers, it is communicated with each other within the LAN is provided by this NetBIOS protocol. Next layer is the presentation layer. In presentation layer, we are the main function of the presentation layer is to provide the encryption, decryption, and representation of data format. In the protocols we are using in presentation layer is SSL on TLS. SSL stands for Secure Socket Layer. Actually, the Secure Socket Layer is nothing but a security protocol that creates encrypted link between the web server and the web browser. Web server provides a security link. While we are accessing some through some websites, if it is we are having HTTPS, it is a secured web. Secured web. If it is not, if we are having only HTTP, it is not a secured website. For that particular HTTPS, that particular organization or whoever using it, they have to purchase an SSL certificate for a period. They can mostly it will be provided for within 1 year or 2 year according to it. TLS is nothing but a transport layer security. It is a similar to SSL protocols, but it's somewhat upgraded version of that SSL. SSL and TLS is the security protocols that provides the security between the web server and the web browser. Application layer is the human interface. These are some of the protocols we are using in the application layer. That is HTTP is hypertext transfer protocol. FTP is file transfer protocol. SMTP simple mail transfer protocol. Then SNMP is simple network management protocol. DNS is nothing but domain name system. Then Telnet dynamic host control protocol. These are some of the protocols we are using in the application layer. In case of internet protocols, we are having two types of protocols, that is static and dynamic. In static means the IP never changes. We used to have a permanent IP for that particular network or particular. We are having separate IP and it is permanent. In dynamic means the IP changes whenever we log in. Actually, usually some private organizations, if they want their data to be secured or they want some access somewhat, when compared to dynamic static protocol, it is somewhat secured and we can access their data somewhat faster. These are actually dynamic means the IP changes whenever new login occurs. We cannot use the same IP. Depending upon which IP is free in the IP pool, it is allotted to the dynamic users. These are some of the IPv4 address range we are using, that are class A, class B and class C. Class A address range starts from 10.00.0 to 10.255.255 and its per network prefix from 10.0.00 to /8 and address range of class B addresses from 170 to 16.0 to 170 to 31.255.255 and class C it starts from 192 to 168.0.0 to 192 to 168.255.255. Then Actually, in IPv6 is a 128-bit addressing. It is somewhat, it has more IP address when compared to IPv6. Sorry, IPv4. It's a proxy server. So firewall, actually the firewall protects us from the some unwanted virus and whatever it is while we are using the internet. Then broadband. Actually, broadband means we used to say it as an always on technology. That is, it is provided TRA is nothing but a Telecom Regulatory Authority of India. That is, it is an authority of, actually it is a government organization run by Government of India to watch over or to regulate the operations and functions of the telecom providers. Actually, the minimum download speed is 2 Mbps in case of copper connections, the broadband. Actually, the broadband is that whatever we say it is, that is always on technology. We can use the phone and internet on the existing telephone line in a simultaneously. We can able to use the telephone line and also the internet. Actually, this is the DSL architecture of a copper broadband line. This is some of the customer end equipments or customer premise equipment. In customer premise equipment, we used to have, that is first one is a telephone, a PC and a modem. Actually, this one is home gateway. We used to say it as a splitter. These are the customer premise equipment. In customer premise equipment, what are the equipments we are having? One telephone, a PC and a modem. Telephone, PC and modem, these are customer premise equipment. Actually, from splitter, it splits the lines for the modem, actually for broadband and the telephone line. This home gateway is nothing but a splitter we are using. Actually, from splitter, it is connected to a DSLAM. DSLAM is nothing but a digital subscriber line access multiplexer. A digital subscriber line access multiplexer, it is a DSLAM. DSLAM is nothing but it collects the data of the different users and it multiplexes the data. Actually, in case of transmitting, it multiplexes the data. That is, it provides some, reduces the bandwidth. It multiplexes and transmit to the BNG, that is BNG or BRAS, Broadband Network Gateway or a broadband remote access server. From remote access server, it is connected to PE and it is connected to, that is a ISP internet provider edge router, and from that it is connected to the public internet. Actually, this is the DSL architecture of a copper broadband. The main function, these are customer premise equipment. Customer premise equipment is connected through a splitter to the DSLAM, and from DSLAM, actually, so many number of multiple customers are connected to this DSLAM. These DSLAMs collects the data from the different customers. It multiplexes and transmit to the BNG. That is BNG or BRAS, Broadband Remote Access Server. And from there, it is connected to the internet. A minimum equipment provided in the subscriber premises, that is a splitter and a DSL modem. PST, actually the DSLAM is an exchange side equipment. DSLAM is located in the exchange of the particular local exchange. Digital subscriber line access multiplexer. This is the customer premise installation overview. Actually, this is the data cable that is we are getting from the DSLAM, and from that this is the splitter. From splitter, two lines are splitted separately for a telephone line and a line separately connected for a broadband access, that is through a modem. From modem, we are connecting the broadband line to a system or laptop, whatever we are using. Actually, in the customer premise installation, we are having a splitter. Along with the splitter, we are having a telephone device, a modem, and a system. This is the picturization of a broadband remote access server. This is the function of the BRAS. Actually, it acts as the edge of the ISP core network, or else in another way we can use, we can say that it aggregates user sessions from the access network. Different users are aggregated in this BRAS server and they are forwarded to the provider edge router or to the internet. ISP injection policy management. This BRAS provides the IP quality of service, aggregates the circuits from one or more linked devices such as DSLAM. Actually, different DSLAMs are connected to a BRAS or BNG, broadband remote access server. Not only BRAS, from different DSLAMs, different customers are connected to DSLAMs, and different DSLAMs are connected to BRAS. And BRAS forwards the whatever it receives it to the ISP provider or provider edge router. It also provides the layer 2 connectivity and layer 3 connectivity. In case of layer 2 connectivity, it acts as a transparent bridging between bridging over Ethernet or ATM sessions. It also enforces the quality of services or quality of service policies. If whenever it sometimes it provides the layer 3 connectivity, that is, it routes the IP traffic through an internet service provider backbone network to the network. In the first architecture itself, we have seen that the BRAS or BNG is connected to a provider edge router. That is, actually it is connected to a this access node is nothing but a DSLAM. We are having different DSLAMs. Sometimes these different DSLAMs are connected to a BRAS, and this BRAS is connected to a provider edge router. These are different types of DSL that we are using in the customers. Actually, different types of DSL available. ADSL is nothing but a asymmetrical digital subscriber line, and SDSL is a symmetric digital subscriber line. HDSL is high bitrate digital subscriber line. VDSL is very high data rate DSL. RADSL is nothing but rate adaptive DSL. ISDN is integrated service digital network digital subscriber line. Depending upon their requirement, they can use usually for individual home or individual customers, they used to purchase ADSL. That is ADSL modem, asymmetric digital subscriber line. These are some of the upload rate and download rate of the modems. ADSL 1, the upload rate of this ADSL is 800 kbps and download rate is 8 mbps. For ADSL 2, the upload rate is 1 mbps and ADSL for a download rate is 12 mbps. In case of ADSL 2 plus, the upload rate is 2 mbps and download rate is 24 mbps. What are the next one? Actually, these are some of the services we are using or accessing through broadbands. That is high-speed internet access, video on demand, IPTV, interactive gaming, e-commerce, video conferencing, share market. These are only some few examples. Apart from that, we are using several services using the broadband. News and travel, music, movie downloads, chat rooms, file sharing, advertising, social networking, telemedicine, teleconferencing, browsing, etc. Actually, till now we have seen only the broadband over copper network. Next, we are moving to we are using broadband through FTTH, that is fiber to the home. Is it able to follow?
Yes, ma'am.
Okay, so thank you. Shall we move on? Okay. Next, we are moving to FTTH. FTTH is the fiber to the home. Mostly at present, we are using only fiber broadband connections. When compared to the main advantage of fiber is when compared to copper, the speed of the data access rate is high when compared to copper. Then apart from that, the maintenance is also very easy in case of fiber. These are some of the bandwidth limitations of ADSL. Actually, it comes under that copper. That is, these ADSL and ADSL 2 plus and all comes under the copper connection. That is download speed and how much kilometer we can able to use. ADSL we can use up to if they are using 0.5 kilometer ADSL 8 or ADSL 2 plus, we can use up to 18. VDSL we can able to use up to 32, and PON in case of FTTH it is high when compared to copper connection. Actually, this is the general block diagram of a fiber connection. This is the optical fiber distribution. Whether we can connect it or from there it is shared. That is, we are using an equipment called OLT, that is optical line terminal. In optical fiber communication, the two main devices we are having is OLT and ONT. OLT is nothing but optical line terminal. That is an equipment that is we are having in a exchange side. That is the equipment we are placed in the exchange premises. In the mode, actually ONT is a customer end or customer premise equipment. ONT is nothing but optical network terminal. Just it looks like a modem. Just it acts as a modem which is placed in the customer end devices. From OLT, actually the connection is through to the customer and using a PON, that is passive optical network. We are having two PONs and PONs and AON. That is a passive optical network and active optical network. Mostly for practical usage, actually most of the FTTH vendors are using only PON, that is passive optical network, since it does not need any power supply or connections for its functions. For example, actually these are optical cables. In case of indoor cable, we are having two types of cables. In case of outdoor cables, we are having separate cables for indoor applications and separate cables for outdoor applications in optic fibers. In case of indoor applications, we are having two type of cables, that is pigtail and patch cord. In case of in patch cord means we used to have connectors at both the ends. One end it is connected to a source and another end it is connected to, definitely it will have a connector according to the device which is to be connected. In case of pigtail, actually in the one end it is connected and another end is left to open. We can able to splice or join one more fiber in the another end. We used to say that type of fiber as a pigtail. In patch cord, actually one end is connected to source and another end is connected to a connector. The connector may vary depending upon the device or equipment, whatever we are connecting. In case of pigtail, one end is connected to one end mostly it is connected to a source connector and another end is left open. We can able to splice or join or extend the network from that end. In case of outdoor cables, we are having separate cables for drop or feeder cables and drop cables or feeder cables. Actually, in drop cables, they used to have 2-core fiber, 4-core fiber, 6-core fiber, and 12-core fiber. In feeder cables, it starts from 24-core fiber, 48-core fiber, 96-core fiber, 144-core fiber, 288-core fiber. Actually, depending upon their requirement and applications, they go for which type of cables they are required, and they go for the particular fiber cables. Next is the advantages of optical access. The main advantages, it is the bandwidth is high when compared to copper connection that we are using in broadband. All IP system. Next, one more advantage is there is no active elements. That is, if you are using PON, there is no power is required for that passive optic network. The lifetime of this FTTH is around it is greater than 50 years, and the operating expenses somewhat lower. Actually, one more advantage is when compared to copper cables, if some optical fiber cables are running in parallel to the electrical cables, if you are using a copper cable, there might be a chance of producing an inductance effect or some signal interference that may occur. But these are avoided in case of we are using optic fiber cables. Actually, this is the FTTH is the nothing but optical fiber right up to the customer end. This is the OLT. We are having some connections, and ONT that is placed in the customer end equipment. OLT is a exchange side equipment, and ONT is the customer premise equipment. Between the exchange end and the customer end, we are having an access network, that is optical access network. This we used to say central office point is called OLT, that is optical line termination. This is the optical line termination. Then from there, a network is extended. We used to say that network as optical access network. From this optical access network, we connect the ONT or ONU, optical network unit, or they used to say the customer premise equipment as optical network unit or optical network terminal or termination. OLT, OAN, and ONT. It is the fiber connection architecture. Generally, it is a central office exchange. That is, we used to have the OLT equipment in the exchange side, or those who are providing some, mostly at present, most of the cable operators are providing our BSNL FTTH connections. They will place their OLT in their office, or sometimes BSNL is also providing connection to the customers, that the place we are placing the OLT device, that is optical line terminal, we used to say it as a central office. From the OLT, the connection is extended through OAN to the customer point. That is, we are having different, they used to have different type of connections or extend the cables until the customer end. For example, they place the OLT here, and they used to have some feeder cables here. From that, they used extend the from feeder cables, it is a connection is extended through a distribution cable to a access terminal. From the access terminal, the connection is extended to the customer end. That is for individual customers. Similarly, there are two type of connections is there in FTTH. Then passive optic network. Actually, now most of the FTTH vendors are using only GEPON and GPON. GEPON and GPON is nothing but actually what does the means? Gigabit Ethernet passive optical network. For a GPON is a gigabit. Actually, GPON and GPON. What is the difference between GPON? Actually, both are same, but only the difference is in GPON, both the download rate and in GPON, both the download rate and upload rate are same. But in case of GPON, the download rate is higher when compared to the upload rate. For customers who are having a somewhat higher plan or a bandwidth, those FTTS vendors may go for GPON device. These are the difference between the GPON and GPON. The speed of the download speed of the GPON device is 2.5 Gbps, and the upload speed is 1.5 Gbps. In a gigabit, that is 1.5. Both upload and download are same. If the both upload and download speed is same, or downstream and upstream is same, we used to say it as an symmetric. If both upload and downstream speed is varies, we used to say it as an asymmetric. So in GPON, these two upload and downstream rate differs. We used to say it as an asymmetric. In case of GPON, actually both upload and download streams became same. The same speed is there. We use so if the both upload and download streams are same, we say it as a symmetric. This GPON is an ITU standard of G984, and GEPON is an IEEE standard of 802.3. This GEPON is used in internet. This GPON is used in ATM, GIM, and Ethernet also. Asynchronous transfer mode. Redundant PON ports is available in GPON, but there is no redundant PON ports available in Gigabit Ethernet PON. This redundant PON ports is nothing but actually two PON ports on the OLT will be there in the, if you are using a GPON in an OLT, two PON ports are available on the OLT. Actually, it acts as a hot backups for each other. Hot backup means if one PON port got failure, it instantly it takes next another port will act as a active port. Mostly but in case of GE PON, there is no redundant PON ports available in the GE PON. This is the architecture of an FTTH. This is the ONT. This is the customer end. We are placing the ONT in the customer premise equipment. From the ONT, the separate line is given for a telephone line and for a broadband connection. We are using some, we used to say it as an SPC, that is space. We used to connect the SPC through OLT, from OLT, different type, from OLT, sending the connection to the customer OAN. We used to have OAN, that is access network. From OLT to an internal network, BRAS, that is broadband remote server. This MGW is used for media gateway. This is used for telephone connection. This media gateway. Hello. Continue. Is there any? Actually, this is a OLT. From OLT, we are having some OAN network. OAN, that is optic access network. From optic access network, we are connecting to the ONT, that is to the customer end equipment. Then OLT, from OLT, it is connected to an internal network, and from there it is connected to a BRAS, that is a broadband remote access server, or a BNG, that is a broadband network gateway. This MGW acts as a media gateway, that is it is used for the purpose of telephone connection, telephony network. Along with the data connection, BSNL is providing the telephone voice call connection is also provided by the BSNL. Actually, the main purpose of this media gateway is it translates, it acts as a translation device that converts the digital media streams between different telecommunications. So that is actually for, in case of voice communication, BSNL using that PSTN network and some other SS7 signaling. These telecommunication streams or digital media streams are translator, that is converted into media streams by this media gateway, and it is connected to a internal network to the BRAS, that is broadband remote access server. This MGW is mainly used for the voice communication, that is not only for voice, some other digital media streams between the different telecommunications. This is the FTTH architecture, that is in OLT, that is optical line terminal. The transmitting download speed is 1490 nanometer. In some cases, it is 1510 nanometer. In case of receiving, that is upload, it is 1310 nanometer. From OLT, we are using a splitter. From splitter, it is a splitter or connected to different customer end or customer premises. This is an OLT. Actually, these splitters are come under these splitters will come under OAN, that is optical access network. Then this is the customer end, that is we are having the ONT, optic network terminal or optic network unit. This is the PON architecture. This is the OLT. The download stream of the data is 1510 or 1550 nanometer or 1410 nanometer. The upload stream is 1310 nanometer. We are having some. Usually we used to have one splitter here. From splitter, they used to connect to the ONT for different customer edges or different customer premises. This is the picturization of an OLT GPON. That the OLT, that is an optical line terminal at an exchange premises. So we are having, this is the photo of an optical line terminal in our exchange. It is an Alpheon OLT. That is, the make is Alpheon optical line terminal. This is the OLT GE PON. That is a optical line terminal GE PON at our exchange. This is the ONT. That is optical network terminal or optical network unit that are placing in the customer end device or subscriber end device. Actually, in ONT, we used to have whatever we used to have some. This is used for connecting the telephone line. These Ethernet 1234 is connected, used for connecting the broadband connection. This is the reset button, then power. Actually, different companies of ONTs, ONT and OLTs is also available. Netlink, Cyrotech, Alpheon, DBC. These are some of the companies most popular or widely used by the FTTH vendors. So it is a media converter. These are some of the signals or see, that is we are having in the ONT unit, optical network unit or optical network terminal. First one is the power supply. Whenever we switch on the modem, the power button gets on. Next one is the fiber. A fiber status of the optical power with OLT. Sometimes what will happen means if there is a fiber cable cut between the customer end and through, if there is a fiber cut or a fiber damage between the customer network, these fiber LED glows to red color. It means that there is a fiber break in the particular customer area. They can identify whether there is a fiber break or whether the fiber signal is coming or not. From the fiber signal, they can able to identify. Or else sometimes some customers may change the user setting. It also a chance for that the broadband is not connecting. From the blink or green signal, the customer or the FTTH vendor who are providing connection can identify whether the connection is throughing from the OLT to the customer end. Next one is the data status. For updated means only when firmware updated. Similar to our systems operating system, there is a firmware is also there for different ONTs. If some for Alpheon, in case of Alpheon, DBC, Cyrotech, they used to have different versions of firmware for different times. If they want a firmware updation, they can go and download it from their website. Then this testing means this testing is used for during testing purpose, it will be blink. When we are lifting the handset, that is we are using the telephone, this phone LED will blinks during the usage of the phone. Next one will go for a PON splitters. This is the central office. That is the place we are placing the OLT. That is optical line terminal. From optical line terminal, we are using some splitters. Splitter ratio, there are different ratios of splitters available. That is 1:2, 1:4, 1:8, and 1:16. Depending upon the usage, they can go for that particular splitters. From a central office, that is OLT. These are, we used to say it as OAN, that is optical network. Sorry. OAN, that is optical access network. 1:2, here 1:16 or different type of splitters. They have extended fiber cable from OLT, and from it they have used a 1:4 splitter. That is, we can able to take 4 output in one input, and we can able to take 4 output. We are using 1:4 splitter. The input will be 1 and the output we can take it as 4. Similarly, for 1:8 splitter, the input will be 1. Whatever splitter we are using, the input will be 1. Depending upon the ratio, the output may vary. For 1:8 splitter, we can able to take 8 outputs. Similarly, for 1:2 splitters, the input is 1. We can able to take 2 outputs. Similarly, for 16, 1 input and 16 outputs. Actually, this is the splitter ratio. That is, for example, 1:2, 1:4, 1:8, 1:16, and 1:32. Actually, these are some of the losses they have identified, and in case of 1:2 splitter, the losses for 1:4, it is a loss is 7, and 1:8, the loss is 10.5. Whenever the splitter ratio increases, the loss might get increased because we are splitting the one input stream into different number of output streams. While the output stream is enlarged, that is widened, the loss there is a chance to increase in the loss. Mostly they used to have higher splitter ratio in the nearest distance from the OLT, and splitter ratio they used to have lowest splitter ratio for in case of long distance communication or long distance customers. That is 1:2, we can able to use up to 60 kilometers, 1:4 56, 1:8 for 44. 1:16 for 32 kilometers, and for 1:32 for 20 kilometers. Whenever the splitter ratio increases, they will decrease the distance. Near This is the picturization of splitters. These are some of the splitter boxes. The same, actually, this is the central office, that is OLT. We are using a 1:2. While giving connection, we are having two type of, we can able to through the connection to the customer using through types. That is, one is centralized and one more is a cascaded. That is, in case of centralized connection, centralized network connection from OLT, we are using only one splitter, and from direct to splitter, they are connected to the customer end. We doesn't have so many splitters in the centralized. From OLT, they will have only one splitter, and directly from that splitter, it is connected to the customer end. In case of cascaded, actually from central office, we are using one splitter, and from this splitter, we can extend. From this splitter also, sometimes they may use some different splitters and until the customer end. This is centralized and this is cascaded. This is the splitter box setup. How we actually, this is the splitters we used to have in the field. This is also, for example, they are using as in central office, they are having that OLT 12 fiber. Kindly mute. Actually, this is a sub-office SC jack unit. That is, jack unit is whenever a fiber cable extended from the OLT to the customer end, it is left open. We cannot directly connect the optical fiber to the modem or ONU or whatever it is we are connecting. So they used to have one sub-office SC jack unit like this. They used to have these type of, actually this is the connection from the OLT end, and from there they used to have one connector like this in the SC jack unit. If the connection is not required, there is no need to splicing. Splicing means joining of two cables, two fiber cables. We used to say it as a splicing in fibers. If you are extending the fiber, or if the customer has no need of connection, just they can remove these connectors. There is no need to splice the cable or cut the fiber cables. They used to usually in the customer end, they use these type of SC jack unit for the customer premises. If the connection is here, the connection is connected to a ferrule connector, and it is extended to one side, it is connected to the OLT or splitter. Through splitter, it is connected to the OLT, and another end it is connected to the ONT, that is the customer end. Actually, this is a device we used to say it as a power meter. It looks similar to a multimeter, and this device is used for actually, if a customer is in need of a fiber connection, first the vendor will check how much loss is there is identified until the customer end. How if the loss is between minus 28 dB and 8 dB, then only the broadband connection can be able to access by the customer. If the loss, that is, if it crosses minus 28 dB, that is minus 30 dB or minus 32 dB, if we provide data connection to the customer, the data cannot be accessed by the customer. It frequently gets disconnected and the data is not properly accessed by the customer. So whenever a customer asks for a connection, first to that is the vendor who is providing the connection. First they will check whether how much loss is there until the customer, and it should not cross minus 28 dB. Sorry, 28 dBm. It is measured by using this power meter. That is power meter. It looks similar to a multimeter. Apart from that loss, it can also measure the power output of some other optic fiber equipment. It can able to measure the power output power and also the power loss. Actually, it is a splicing machine. That is, splicing machine is used for, that is, if there is a, for, if splicing in terms of fiber, splicing means joining of two fiber cables. Two fiber cables. Actually, the practically the network will have from an OLT in the exchange side, and in between we have the access network. That is, we have some splitters, and from splitters we run the fiber cable unto the customer end. If there is a chance to fiber cut in between in the access network, if there is a fiber cut in the access network, the customer cannot access the data or voice call, whatever it is. So we have to join those two fibers. That is, wherever the fiber is cut, we have to join those two fibers. In case of joining the fibers, the technique we are used to say it as a splicing. Joining of two fibers is a splicing. For joining of the fibers, we have, that is for splicing, we are having one special machine called, that is, splicing machine. This splicing machine is used for joining of two fibers. Actually, inside the splicing machine, it looks like this. Whatever the fibers are to be spliced, actually this is the center point. We can able to open this end and we can able to open this end. This is a one fiber and this is a another fiber. First they will remove the entire outer layer of each and every fiber layer, and until the center part it will remain, and they will place the one end of the fiber in this end and another end of fiber in another end till the tip of this needle. There is one what we say, that is we can able to close this machine. After closing this machine, actually we'll have one button called arc button. If they press that arc button, an electric fusion arc will be developed in the splicing machine. Actually, this is the outer. We can able to open this end. While we open this, we can have this. Actually, this is the inside of the splicing machine. We can able to open. If you open this, we can have that. We can able to place the both ends of the fiber. In the outer layer, we have a display. If sometimes if you are not placing the fiber in exact position in this place, sometimes it may, if you are not placing the fiber, if a fiber is mispositioned, if you place the fiber misposition means, and if we spliced like that, the loss may increase. So before splicing, the position of the fiber should be verified. The position of the fiber can be viewed in this display of the splicing machine. There is one arc button is there. If we place both the fibers in both the ends exactly, we can press this arc button, and electric fusion arc developed, and both the ends of the fiber gets joined. This is another device they are using in FTTH, that is optical time domain reflectometer. This optical time domain reflectometer can identify where the fiber cable cuts. We can able to identify the place or distance. We can, if a vendor is providing a fiber connections for a rural area, if there is a fiber connection or a fiber cable cut in a particular area, that there may be the customers may arise that they are not getting connection. The FTTH vendor cannot go and search each and every street where the fiber cut occurs. For this purpose, they are having a device called OTDR, that is optical time domain reflectometer. In this optical time domain reflectometer, if they insert, there is provisions for inserting the optic fiber cables, and if they are transmitting it, it will display the, in x-axis, it will display the x-axis, it will display the distance, and in y-axis, it will display the signal level. Actually, the signal level will be high until the fiber is not there is no fiber cut. Once it identifies the fiber cut, the signal level will drop down to 0, and sometimes it may leads to a negative value. They can identify from that place, from till actually x-axis shows the distance and y-axis the signal level. From there, where they are inserting the OTDR, they can able to identify at which place the fiber cut has occurred, and they can able to go and splice the fiber. This is the optical time domain reflectometer. This is the joint closure. That is, after splicing the cables, we cannot left it open as such. If you are splicing the fiber cable, it should be placed safely. Whenever we are splicing the cable, actually the outer layers of the fiber, we'll remove the outer layers of the fibers. Only the inner layer of the fiber will be spliced. Before splicing, they will insert a sleeve like, that is, it looks like a refill pins. They will insert in one end of the fiber. After splicing, they will move the particular sleeve to the spliced end, and they will not, we cannot able to leave the splicing for spliced fiber in the open end. It is not advisable, because there may be a chance for, again, there is a damage of the fiber cable. So whenever they splice a fiber, they usually place it in a joint closure. This is the joint closure box. Actually, inside this closure box, we have an arrangement like this. These are the spliced fiber cables. This one we used to say it as a splicing tray. They will arrange the spliced cables in the spliced tray. Depending, actually, this is the spliced tray. The splicing cables are placed in the splicing tray, and this splicing tray is placed inside the joint closure box, and it kept safely in the network. These are some of the vendors. Actually, that is Alphion, Icom, Sterlite. Apart from that, Cyrotech, DBC, Netlink are some of the vendors available now in OLT and ONT. These are their default username and password. These are the IP addresses of the ONT. For configuring of the ONT, they have to log in with this IP address. This is the some advantage different. Some of the problems that may occur in the network during the occur in the network. These are some, that is the connector damage, connector misalignment, fiber break, fiber bend. Actually, fiber bend is also a problem. That is, we should not bend the fiber very sharply. We should not bend it like this. Actually, the fiber should have a 1 meter around. Then only we can enable to reduce the bend loss. If we have a fiber is such or install the fiber in such a way, actually the bend loss is more, and sometimes it may leads to the fiber break also. Then power level problem of ONU and ONTs, hardware problem. These are some of the problems that may occur in the different parts of the network. While handling the cable, we should not coil the patch cord less than 1 hand span diameter. That is, we should not rotate or coil the fibers very in a smaller diameter. The diameter should be at 1 hand span. Then only the fibers can able to reduce the bend loss. And after that, we should not pull the patch cord firmly at any cost. We should not. If we pull the patch cord, there might be a chance for there is a connection between the fiber and the connector, and there is a chance to loss of signals. Then install a SC jack unit at premises for avoiding damage of cables and easy restoration of usually at the customer end they used to have these SC jack units for easy restoration of patch cord. If the customer is no need or for extension or some whatever the work for future work, if they have a patch cord, they can able to extend or whatever, they can make it easily. Overhead or outdoor optical fiber cable should not be coiled less than 1 meter. That is, we should not coil or make coils with the less than 1 meter diameter. If we make it less than 1 meter diameter, it may lead to a bend loss and there is a chance for fiber cable to get cut. That's it. So, do you have any doubts? Shall we wind up or
I have a question.
okay, sir.
Actually, I'm working in an institution where BSNL network is coming. Sometimes that data connection is very good, but sometimes it is very poor. So what could be the reason, ma'am?
Actually, there may be some reason due to some traffic issues also there, sir. Due to some peak hours, actually the most of the customers might be using the same network. If you are accessing, if there is a difference between the data stream while two customers are accessing the network, and the same while the same network is used while at peak hours, more customers may occur. But that what it happens, the traffic might be increased. There might be a chance for that due to this traffic, the speed may vary.
Okay, ma'am.
Okay. Thank you. Shall we wind up? Okay, thank you all. Tomorrow we'll meet in, tomorrow you can join at 6 o'clock in another session. Thank you all.
Thank you, ma'am.
Okay, so thank you.
Thank you, ma'am.
Okay, sir.
Thank you, ma'am.
Okay, thank you.
Thank you, madam.
Thank you.